This is a slightly different one. The one we skipped is going to be pretty much like the one before. We're going to be looking at a distance and all that. Of course, there's always that little twist, and we may go back as a review on Thursday to some of these that I've skipped, but I want to make sure we cover this one. Okay, a conical tank, vertex down, is 10 feet across at the top and 12 feet deep. This one you're given a little diagram for. Water's flowing into the tank at a rate of 10 cubic feet per minute. There is a very important statement. Did you pick it up? What gave it away? At a rate of 10 cubic feet per minute. Next question you need to answer is, what is that derivative? From that we would get, and this is part of our given, cubic feet. What does that, what measure uses cubic units? Volume, okay? So the derivative of volume with respect to T is 10 cubic feet per minute, okay? Find the rate of change of the depth of the water when the water is 8 feet deep. Find the rate of change of the depth of water. Rate of change of the depth of the water. Once again, immediately, your derivative radar should go off. We are going to have to find, now you can't, maybe you can't see it from my diagram here. If you have it in your notes, there's an R right there and there's an H right there. H is for the height of the water. Didn't want to use D because D is, unless we made it a capital D, so we have an H there. So we're trying to find the derivative of with respect to time. When what? When H equals 8 feet. Okay, what are we going to use? This is one that it's not given to us, but you might know it. Well, do you know what it is? I know it's the volume of the cone. I could have told you that. Okay, now volume. Okay, remember volume of anything. Let me just draw you a quick little diagram here. If we have a, whoops, that's supposed to be a box there. If we have a regular parallel pipe, a box, whatever, we look at volume, we're looking at length times width times height. Length times width. Volume is always measuring the base, okay, times the height, okay? So what we've got here is the base is a circle, so that is pi r squared, and then the only other piece is, imagine if you took these, took 3 of these and alternated base up here to base down here. It's actually 1/3 pi r squared h. 1/3 pi r squared h. So one of these is 1/3 of a slanted rectangular box. Okay, you don't need to know that. Again, if you needed to know this on a quiz and I didn't give it to you, just come up and ask, and I would share this, because I'm not testing you on this. What I am testing you though is how are we going to get to our answer of the derivative of height with respect to time. Now, the volume of what? What are we finding the volume of? This whole thing? So, do you see 2 cones that are very similar? Okay, if you have 2 objects like that that are very similar, they can be angles in a, you know, the angle from my feet to the top of the wall is similar to having someone stand at, you know, if I had a line drawn up here, someone standing at touching the line. I mean, they're creating another triangle that's similar to mine. This is how we do trig, by the way. I haven't had a chance to do all my trig stuff with you guys, but trig's the same way. We set up, we call them proportions, 2 ratios. set up proportions, and we need to come up with, you know, we can get the volume of the whole cone, but it's the volume of the water cone that we're looking at. And so I need R and H here, and I need to, let's see, I'm trying to find dH dt. So wouldn't it be nice if I didn't have any R in my work? Okay, and if I take the derivative of this, I'm guaranteed I'm going to get a dr dt somewhere, and if I can avoid that, I will. So the proportion is going to be what? 5:12 as R is to H, which tells me that R has the same representation as 5 times H divided by 12. Now, I'm going to use your video, hoping I don't go over 14 minutes here, because in the last class, we worked it out without doing that. It was kind of a headache, okay? Because I forgot that we needed the proportion sooner rather than later. Now, if you do it later, you can still go back and do this, but you know, if I showed you that video, you'd see, and it's not pretty. Okay, so I'm going to do that. I'm going to have volume equals 1/3. In fact, let's make this pi divided by 3. And then I'm going to have 5h divided by 12 quantity squared times h. Let's see, we can clean this up as 25 pi divided by 36 h. Oops, that's not right. I wish it were that simple. So let's make this, oh, that's not it either. Okay. Let's make this, unless someone knows there are 144 tables, 3 times 144 for now. I'm squaring 12, that's 12 squared is 144. I squared 5, that's 25. That's how I got 25 divided by 144, and I have pi divided by 3. H squared, that should be h cubed, shouldn't it? Okay? That's going to be a much easier problem to find the derivative of than what we did in the first class. We haven't taken a derivative yet. I think it's time. Okay. So everything here is a constant. So that's 25 pi divided by, who has that number? Yeah, 432. Okay, now I need the derivative of h cubed with respect to time. So that's our composite functions there. So we're going to have 3h squared, okay, times the derivative of with respect to time. What am I trying to find? dH dt. Okay. H. That was one of our given pieces, right? Okay, so find that when h is 8. So, you know, we could go through, oh, and dV dt, that's given, that's 10. Okay, so we've got 10 times, let's see if we can do this, 432 divided by 25 pi times 3 times 8 squared equals dH dt. Now if I did that correctly, I took the reciprocal of this, so 3h squared is also in the numerator, h is 8. And then, of course, you need to go through and do some work. Make sure that, you know, we've got values there. It turns out to be, or should turn out to be, 9 divided by 10 pi. 9 divided by a 31 or so. Yeah.
Can you take the derivative of a constant? I thought it was just a...
It is. So,
because it's the change.
well, but I see a product rule here. So I've got the product of the constant, if you want to do this way, the coefficient times h cubed. We also have the power rule that says you take the exponent times the coefficient. Okay, so that would be another way of justifying that. So this is, I've got to be approximately 0.287. What are my units though? Feet per minute. So what are we finding? So when you think about this, now as I pour water into this tank, is the height of this, Eric, is the height of this, the height's always increasing, but is it increasing at an increasing or decreasing rate? Because as I get up to the top, I've got more of a area to disperse the water, so yeah, it would be increasing at a decreasing rate, which is the opposite of what MacGyver had to deal with. Okay. Let's go back and look at this. How would you know to do this problem on your own? And by the way, that is the most important thing you're going to do later today, is go back to these very same problems and rework them without looking at the notes at all. Now, I can almost guarantee you, you're not going to get these problems done this afternoon without looking at some notes. These are not the type of problems that you have a simple step. This is the type of problem where you have to look at it, read it 2 or 3 times, draw the pictures, start it, maybe stop it, start it again, stop it again, because there's many, many pieces to this. And the best thing you can do is to say, okay, I'm going to do the best I can today. And by the time I quiz you on this and give you a test on this, you're going to have a pretty good understanding of how we need to work with these. And again, there are people in math lab who I can guarantee are going to say, let me give you to someone else, because they don't understand the problem. They don't feel confident with that. And I want you to feel confident with that. They're not the easiest problems, but they're not impossible either, if we find our way through them. Okay, so we have to look at what are we given, and whenever you see the rate, something's working or moving or increasing at a rate of, that's going to be a derivative. And look at what we're talking about. This is feet, cubic feet, so that means volume. There's lots of key words in here, so pick up on those key words. Okay, yes?
So how did you find the rate?
Because we are dealing with, the water is at 8 feet, and we want to know how fast is this height, this depth of water changing. Height, you know, the depth of water is in feet. Okay, good question though. One of those that we don't stop and think about. Okay, I'm going to stop this.